I'm a Community and Economic Development Specialist for University of Illinois Extension. Before introducing our topic and presenter today, I want to let participants know you may write questions into the chat space at any time. Also, if you have any problems connecting, add those questions and concerns to the chat space as well. We will monitor the chat and I will relay the questions to our speaker at the end of the presentation. Please note that participants will receive slides, links to resources, and a link to a recording of today's webinar following the webinar. Today's webinar is Scaling Up to Millions of Electric Cars, Solving the 90% Energy Problem for EVs. We are excited to have Dr. Philip Crean as our presenter. Dr. Crean has been working on electric and hybrid cars for more than 30 years. He is the Granger Endowed Chair Professor Emeritus in Electrical Machinery and Electromechanics at the University of Illinois Urbana-Champaign. He is a past president of the Institute of Electrical and Electronic Engineers, or IEE, Power Electronic Society. He's a past chair of the IEE Transportation Electrification Committee. He is also an IEE fellow and a member of the U.S. National Academy of Engineering. In 2021, he received the IEE Transportation Technologies Award. Thank you so much, Philip, for being here, and I'll turn it over to you now.
Yeah, thank you, Zach. It's good to see a big variety of attendees here from really all over the state, up and down. I saw at least one from Indiana as well. And I don't want to get super technical today. I'll try and keep this at a fairly high level. And I don't want to try and cover all of the issues all at once, but I do want to plant more than just a few seeds and try and get folks thinking a little bit differently about the infrastructure we need as we vastly scale up with this. Because I think in many ways, we try to make some of these problems a little bit too hard. So I will be talking specifically about a topic I call the 90% energy problem, specifically for passenger electric cars. And I do want to emphasize that the conversation here is really directed at light duty vehicles. The considerations for delivery vehicles and taxis and medium duty vehicles and of course heavy trucks are fundamentally quite different and require a little bit different perspective. And although we can maybe have a little bit of time for discussion of that, I don't want to try and hit on that too much at this point. So let me go ahead and get these slides to cooperate. The work has been supported by the Granger Center for Electric Machinery and Electromechanics at the University of Illinois Urbana-Champaign, but also some work jointly with collaborators in China. So believe it or not, we actually have some data from the China side that kind of back up some similar issues. And again, I'm trying to emphasize passenger cars here. Now, people have a temptation to try to map electric vehicles back onto fuel-driven vehicles, but really this can head people kind of in the wrong direction. The average daily car travel in the United States is 29 miles. And according to federal survey data, 95% of US daily passenger car trips are less than 31 miles. So the notion that we need lots of range all the time is a little bit misplaced. We certainly need lots of range sometimes, but perhaps not all the time. And the data have to be interpreted a little bit. I know it's hard to see the color codes on this screen, but basically what you find is that in the urban areas, the actual daily trips are relatively lower. And in some of the rural areas, they're relatively higher. And many of the people on this call know of areas where people have to travel a significant distance just to get to the supermarket. It's not just West Texas where people have to travel 100 miles to get somewhere. Certainly there are places in Illinois where a 20 or 30 mile trip is kind of a routine thing to meet general need. Even so, daily trips, especially in urban areas, tend to be at modest speeds. And if you'll indulge me, basically 250 watt hours per mile becomes kind of a rough rule of thumb for urban driving energy consumption. And we'll put that in context here a little bit later. But what this means is that, because we're looking at sort of the 95th percentile, and it's only that last 5% of trips that are longer range, you do some math and you say, well, gee, this means that maybe up to 90% of energy is kind of consumed in these short daily trips rather than the long distance trips. And that has a lot of implications for what we should be doing in terms of infrastructures, especially in terms of how we scale it way up. Well, it's a fallacy, a well-known quote. An electric car needs to do everything we can do with a conventional fuel-driven car. I would claim that this is a fallacy. There's plenty of differentiation even today in transportation markets. And in fact, electric vehicle owners, so far, the baseline data says that they don't use their cars quite the same as they do fuel-driven cars. And we can go back historically. One of my friends pointed out to me that this photo I managed to find from a museum site in New York is actually an image of a horse stable from the early 20th century that has been rewired and converted over to be an electric vehicle stable. So the point here is that at that time, electric cars were basically treated as if they were horses. You would take your vehicle to this kind of place overnight where it's sort of watered and fed, so to speak. And the next morning you send your driver or you yourself go and retrieve the car and use it for the day. Obviously, we've come a long way past this, but you can see the temptation to map a new technology back into a conventional way of doing things. And that's usually a dangerous way to think about things. Well, when we look at the implications of that, there are lots of implications, especially for business models in fuel distribution and so forth. As all of us know, nearly all fuel is distributed from filling stations, and they have lots of internal storage. So a tank underground in a gasoline station typically has enough fuel for perhaps 1,000 cars. And none of us wants to store lots of gasoline at our homes. So the model is pretty clear. You have large scale storage at a central location. You go and take advantage of it every now and then, transfer some of it into your vehicle, and then use that. That model really doesn't map for EVs because, first of all, we can't really store electricity very effectively. And second of all, we all have access to electricity at places where we live. So you have a business model problem. What owner of an electric vehicle wants to drive to a filling station to meet their 95 percentile daily driving needs for that 90% energy use? The fact is that if they can find a different way, they will do that. So the premise here is we have to come up with much more convenient, much more cost-effective ways for people to charge up. It's a lot different from an electric vehicle owner. If you can do it, you just plug it in. And here's a couple of typical vehicles. And that photograph on the right is actually a lamp post that I took a picture of in Lincoln, Nebraska. It's got an electrical outlet. It's locked up. But, there it sits. It's potential electric vehicle charging infrastructure. A basic outlet that we're all used to in the United States, 120 volt outlet. By code, you can draw up to about 12 amps out of it without thinking too hard. Internationally, the voltage is higher, but the current's about the same. And of course, we can get to these in lots and lots of places, not everywhere where we want to, but very familiar. And what about this? Well, you go through the math, and Tesla Motors is very famous for converting charging into a speed. So when you're plugged into a basic outlet, you're charging your car at a rate of about 5 miles an hour. And boy, that sounds really slow, but a passenger car is parked almost all the time. and trying to get to 30 or 35 miles or so, or that kind of a value for range is pretty realistic. Now, if you could get to sort of the international level where you've got a 220 volt outlet, it's roughly twice as far, roughly twice as fast, 10 miles an hour. Still takes some time, and people think this is really slow, and we'll come back to that. Well, what about the next level? As many of you know, there's a lot of incentive to install these kind of dedicated charging points. Typical levels are 6 or 7 kilowatts. That's a higher rate, 25 miles an hour kind of thing. That's really not fast enough to support long distance driving. And frankly, it's not really necessary for most commuting kind of duty. You know, that 95th percentile at 30, 31 miles a day, you know, do I really need this? The car's parked many hours a day anyway. Now, of course, fast charging is not something we can ignore. You need it for distance. It's a separate issue, has to be addressed, very important. One of the considerations that we deal with all the time is that fast charging is going to be inherently much more expensive. Whereas charging with a much more basic outlet it is a more modest cost kind of an argument. So people are going to see pretty significant incentives to use it only when they need it. All right, so thinking about this and putting some numbers together, and I'm getting a little bit technical here, but basically you can say 95% of the time you park your car and you're looking for no more than about 8 kilowatt hours to kind of bring back enough for meeting day-to-day energy needs. Yeah, you do the math, that takes more than 6 hours. The good thing about it is it doesn't stress batteries. You're charging them really slowly. They prefer that. So there's really no wear and tear. And especially in a full-blown electric vehicle, you know, the stress level is very, very modest. Not something that anybody's going to be concerned about. And the energy cost of that much electricity is also very modest, roughly $1 worth. And as a result, some people are looking at different kinds of solutions. My favorite is a project going on right now in Finland. In Finland, there are roughly 3 million passenger cars. And it turns out that there are roughly 1 million parking spaces with basic electrical outlets that are there for winter block heater duty. I'm sure some of you know what that is, maybe grown up in even more northerly climates than where I sit in Champaign-Urbana. But in any case, outlets for block heaters, pretty routine in that kind of place. And several entrepreneurs realized that all they really need to do is slap a sign on those and say, here's an EV charge point. And bingo, suddenly there's 1 million places to charge electric cars in Finland versus 3 million cars. Kind of clever, and as it turns out, extremely effective. Well, the problem as we scale up, you know, these dedicated charge points, which in the industry lingo are called level 2 charge points, the only way to make the economics work is to get really intensive use. And that means lots of hemming and hawing about where you put them, where you get the capital investment, how are you going to recoup any of that. Typically, we see discussion of trying to put them at roughly 10% of spaces. As many of you know, this raises questions about electric vehicle charging etiquette. How long am I allowed to be at this space? Do I need to move my car? Can I use the space for an hour? These are a lot of headaches that I just, I'm not happy about trying to reintroduce them into the public arena. And I want to point out that picture at the upper right. This is a company in New York that wants to install nice, fancy level 2 chargers. And their original proposed rate plan was to charge people about $2 an hour. This lady seems to be pretty happy about that. If she does the math, she'll find out that she's paying 5 or 10x for that energy compared to what she'd be getting in a routine, just regular outlet. And she's going to have to move her car after an hour so somebody else can get to that. So an hour from now, she may not be quite that happy anymore. On our own campus, we have found that these level 2 chargers are being used only a few hours a month. Whereas any place where you can find a basic outlet in a parking structure that's got a sign on it's allowed for EV charging is pretty much used just about all the time. So these fancy dedicated chargers are certainly going to have an energy cost premium on the order of at least 50%, maybe even more, to try and make their economics work. The pricing we're seeing in the real world is even higher than that. Some of you may have Teslas and may be part of the distance network. And as you begin to see that going away from a free service to a build service, you'll see quickly what I mean in terms of how the costs start to pan out. Basic receptacles can make this a whole lot easier, right? There's another lamppost in Lincoln with a cover off, and it's just a regular outlet. We can, I mean, some of these are artist renditions. In principle, putting a regular outlet in a little bike parking post or some kind of traffic bollard, or even in a parking meter, which may have an electrical supply already for its billing and communications, certainly on the outside of a building where people can get to it easily. These are things that I think all of us can relate to and understand. Obviously, in the US, there are plenty of outdoor outlets already, but expanding that is something that we can certainly wrap our heads around. And I want to think about some basic scenarios just to put this in context. So I'm trying to think of a small town somewhere in central Illinois, and here's some basic scenarios that one might be thinking about. Certainly their employees, there are residents, they expect to be parking several hours a day. There might be visitors coming in to shop or to have a meal. They may be parking for a couple of hours, and shorter visits, people might just park for 1 hour. And if you think about it, you can realize that the basic receptacles are very much matched to the needs of employees and residents. Any place where I'm going to be parking a car for many hours, very low cost solution, convenient, easy enough to have several outlets on the outside wall of a restaurant or whatever it might be, or again on parking meters in a central area in a village or something like that. Granted, level 2 charging is nice for shorter visits. If people are paying significantly for parking, then the energy cost maybe isn't a big deal. Today, it's pretty typical to have some overpricing, although I'm certainly familiar with places in Champaign where this is considered a free service and you pay for the parking and you get to plug in as a bonus, which sounds great and is convenient, and I use that when I can. On the other hand, when you do the math of how much you spent on parking, people are doing just fine. The energy cost is pretty low. Fast charging, we are starting to see some development. Truck stop operators are beginning to understand how this can work out and install much faster charging, where maybe you can charge your car significantly in 20-ish minutes. We know how to do that. The technology is certainly developing. I see lots of technical papers about this topic. The energy cost is not nearly enough to cover that. So the cost will be a significant premium. Necessary for distance travel, no question about it. Not something where you're getting your day-to-day low-cost energy. But I think any of us who try to take our electric vehicles and go a significant distance understand that, yeah, we're going to pay a bit of a premium for that convenience of using that vehicle over a long range. Well, I like to think about problems in sort of a reverse way, start at the endpoint and see if I can work backwards. Frankly, I think we know where we need to be, certainly well before 2040, maybe even by 2030. We need to have receptacles readily available at places where people live, at places where they work, maybe at places where they shop. We need to have a more modest fast charge infrastructure to support long distances. Remember, that's only going to be 10%-ish of the energy flow, so it's not like the present filling stations. And we need to have communications, billing, coordination, and some other basic infrastructure to make this work out. Simple example is my phone. My cell phone could certainly have a little app on it that can turn an outlet on or off at a location where I'm parked, basically telling that outlet to bill me for the energy service for the connection. This is something that is straightforward enough. It's a little bit unfamiliar in the electric utility industry, but it's typical in a lot of other contexts. So, something we know how to do. So the idea is, given that endpoint, how do we work backwards through to today, to 2022 or 2023, and accomplish what must be done? What do we need for communications and safety and reliability to provide people with general access? Now, in some ways, that problem is not as hard as we like to make it out to be. The photograph on the right there, I took right walking down a sidewalk in Champaign. Plenty of places where there are light posts and electrical access. We should be able to figure out how to implement that. Lots of places where there are parking meters. Many of them also have some basic electrical access today. Can I turn them into EV charge infrastructure? Probably, and maybe without a lot of extra cost. We certainly need some communication linkages between vehicles and broad infrastructure to make this work out. The interesting thing about this is you don't need much information. The car can measure its energy flows and electricity usage and send it out, maybe even just once an hour to the provider to say, okay, here's how much I use. This is the billing thing. Obviously, we have to secure that, but there are many techniques known to try and do that. And the onboard charger inside the vehicle needs to be able to do active safety management, make sure there's no problems with moisture or other things, and then turn on and off accordingly. Here's another block heater picture that I found taken in Regina and Saskatchewan in Canada. Again, block heater outlets are everywhere. They're ubiquitous. Some of my friends look at this in horror and say, oh, it's a terrible safety issue. Well, not really. Those outlets have ground fault interrupters on it. People do this routinely every winter. There's cords going through snow and ice, and it's electricity. Yes, it has safety limitations, but it's familiar. We all understand this, and it's done routinely. And I look at that picture and I see a forest of EV charge points. Very, very straightforward infrastructure. And again, I don't want to be too technical, but we do know how to use electronics so that we can add the safety features and some of the other protection kinds of things without making it too hard. And I'm not going to explain this. I will tell you, I have a couple of students actually working on these kinds of technologies to make them real and making them into something we can actually implement. They would actually go into the cord that's connected to the car rather than into either the vehicle or the outlet. Well, let's do some of the basic economics and get a sense of this. The average US electricity retail cost is about 12 cents a kilowatt hour. In Illinois, it's slightly less than that, but it is a little bit location dependent. So you do the math and you say, okay, if I'm plugged into a basic outlet, I'm using roughly 17 cents of energy per hour. Now, if I'm a restaurant owner and I'm willing to put some outlets on the outside of my building, I suppose if I can figure this out and say, hey, come to my restaurant, you can charge up for free. If I can attract just a couple of extra customers with that sort of a come on, 17 cents of energy per hour per vehicle is pretty modest. And if I'm really clever, maybe I have intelligent switches on those outlets and there's a point of sale terminal inside and the person actually has to come in and say, yeah, I'm a customer. I want to have lunch here. I have my vehicle charging at space number 4. Please turn the outlet on. There are plenty of business model ideas that can come out in the future. People ask me all the time, how long does it take to charge your electric vehicle? And boy, it takes such a long time and so on and so on. I hear that all the time. Oh, I really want fast charging. I don't want to sit there for a long time, whatever. Well, the connection time is long. The driver's time maybe is a different story. With my vehicle, for example, I take it home at night and I've timed this, okay? I grab the connector off the wall, I open the flap, I plug it together, takes me 8 seconds. The next morning, I come back, I unplug it, I hang up the cable, I close the flap, takes me another 8 seconds. So it takes me 16 seconds to charge my car. I don't care how long it takes Ameren. And frankly, I'm willing to give them a certain amount of flexibility in terms of when they might accomplish that, as long as the car's full the next morning. So the driver's time is pretty modest. And what we see is that people who have the choice, people who have plug-in hybrid cars that can run on either fuel or on electricity, very quickly seem to learn to hate gasoline stations. And let me put that in context, because I have a plug-in hybrid. When I want to go get gasoline in it, I got to figure that out. I got to drive over to the station. I put my credit card into the reader. It always fails the first time, so I got to do it again. Then I pump this smelly, noxious, very flammable liquid into my vehicle, finish the process, put the nozzle back together, drive my car home. If I'm lucky, the process takes me 20 minutes. So I can charge my car about 60 times for the amount of time that it takes me to go and put fuel in it. And of course, very quickly, if I can avoid putting fuel in it, I will do so. I have friends who have done some perverse things. I know one lady who has a plug-in hybrid car, and if it's ever kind of low, she actually grabs her husband's fuel-driven car and drives that instead, because she absolutely does not want to take that car to the gas station. Now, she shouldn't be doing that. It's silly and expensive, but you get the idea. People change their behavior when they get involved with these vehicles. Now, I do want to be a little technical here, because I think this is actually in the long run, this is pretty important. We talk about the interaction with electric vehicles and the power grid. And it turns out that interaction is really only useful when a car is actually connected. So a connected car is a flexible car. If you're doing a fast charge in a car, you're just trying to grab as much energy as you can in the shortest amount of time, no flexibility. But if you have just this basic outlet and you're plugged in overnight or whatever, there's an opportunity for significant flexibility. In this graph, I know it looks a little busy, but it basically compares two scenarios. The one with the bold dashed line there is one in which I have basically, the car has said, I need a certain amount of energy. And I've said, fine, I want that energy by 7 a.m. tomorrow morning. Please talk to the grid and find out the hour by hour pricing and figure out how to charge the car to minimize the energy cost while still not going beyond a certain charge rate. Don't charge too fast. I want to keep these batteries really modest. Don't push the limits on my outlet. Stay within all these limits, but minimize my cost. And the car quickly figures that out. It only takes a few seconds to do that computation, and then schedules hour by hour all night long, giving me the charge the next morning. You kind of see how that goes in a stepwise fashion. So here I have vehicle side control that uses flexibility and responds to hour by hour pricing from the electricity grid. Strictly from the driver's perspective and the car's perspective, there's actually no direct interaction with the utility except the bill at the end of the month. Now, the other one that's really noisy and fine and moving around a lot is one in which instead I said, you know what? I don't care how the car is charged. I will let the utility company figure it out. Utility, you have whatever control you want. Just make sure you give me the energy I've requested by 7 o'clock tomorrow morning. I don't care how you do it, whatever. So in this case, the hypothetical case is actually the utility using a dynamic grid regulation signal and adjusting my charger dynamically to get kind of the best possible services back to the grid. Presumably, they're going to give me an even bigger discount for that kind of service. But basically, the charging control is being given over to the utility company. You can see it's a lot busier, but it still gives the same result at the end. And by the way, it never goes to zero, never goes below zero. I'm never pulling the energy out of the batteries. It's only a one-way kind of a thing. Both of these scenarios are significant advantages to the user and to the grid because they reduce grid stress and they reduce cost. So very interesting to try and match these things up moving forward. So summarizing a little bit, we can go through this and you realize that maybe 10% of passenger vehicle EV charging energy is likely to be from fast charging. No question that will be a premium cost kind of a service. And we kind of know how this would work. Expressway rest areas, near exits. Tesla Motors is building up a network, and so are some others. In the long run, maybe we even have wireless charging built into interstate highway roadbeds. There are some other methods people are talking about as well. But 90% of the energy needs really can be supported from basic outlets. Obviously, in new construction, that's pretty straightforward. It's really not that hard to retrofit. It's quite plausible for surface streets, for street side parking spaces. It's really easy in a parking garage, but it's certainly not hard even up and down a street. And the vehicle then manages the safety and the billing and a lot of the other attributes to make this work out. There are models. There's one that one of my colleagues took in China. Basically, these electric scooters are ubiquitous. And the way this works is you find a place where there are outlets and a little control box. And just as I was alluding to, you pull out your mobile phone and bring up the app and say, okay, I'm putting my scooter and plugging it in at space number 15. And please go ahead and charge up and charge me for the energy. And actually, the phone app probably has money already sort of set up in it to make that happen. You put maybe a few dollars a month into that and then bill against that resource. So we're doing this globally at a fairly low level, and I think something we can learn how to expand. And this is the kind of thing we're getting this to 1 million or 100 million kinds of points in the United States is, again, something we can certainly wrap our heads around. So I wanted to make sure we had plenty of time for questions and discussion. Thank you very much. I want to see if I can bring up for myself at least that chat window without stopping the sharing here. It may not let me do that, actually. So Zach, I'll let you summarize some of the questions. I'll try and get to them. I cannot see the chat right now, so I'll let you.
Sure, no problem. Yeah, I can just provide a little bit of the comments and questions from the chat. We had one comment that urban communities are challenged to have shopping and dining options, so they need to see other scenarios for charging. There's a comment that was made. Someone said that the 120 volt outlets would be great for e-bikes as well. And then we had a question: how do we deal with the criticism that we're working with China to reduce mobility in rural and semi-rural areas, particularly among the less affluent?
Well, I think one of the key points, it's quite clear that an electric vehicle with 30 miles of range is not going to resonate with anybody. The notion that 95% of the time you're just using that for daily needs doesn't mean that that's the design point. And I think the industry certainly has embraced this. I mean, they're not talking, right? They're building vehicles with 200-300 mile kind of range. Yes, absolutely. We have to be at the point where we have proper services for rural areas. I think one of the key points is that expanding basic outlet access in a rural area is a much easier conversation than let me install fast chargers in some rural location. Whenever we talk about fast charging points, we're talking about significant grid infrastructure, substations, this sort of thing. Once you figure out, if I want 20 fast chargers at a truck stop, the energy level is actually that of a very sizable town, a town of many thousands of people. And that's not, let's just go put that in and connect it. That's a significant project. That's like putting in a new factory or a major industrial park or something else like that. So, it's nice to get some data from China, but, in the end, we have to think about the much broader needs that we have in the United States. I hope that's answering the question.
Excellent. We had a comment/question. I saw a pic from a friend in London yesterday with her EV charging from a light pole for free whilst parked on the city street. It looked like level 2. What level of local government investment do you think that entails, both initially and ongoing? And then sometimes cities and towns like to see their downtown businesses accessible without the barrier of parking costs. So how do you sort of rectify or reconcile those two?
For sure. Let's put some of that together. I mean, certainly in the UK, a typical outlet is going to be 240 volts. And it's not especially difficult to put in one that maybe can deliver 20 amps. You are at a level that in the United States we would call level 2 without really doing a very special infrastructure. And that's nice. It's great that they can take advantage of it. I think the important point is they've kind of done the math and said, okay, what is the energy cost? If we let people park for free, what is it we're giving away? And again, in the US with 120 volt outlet, if it's really 17 cents an hour, I've got to wrap my head around, do I make that a free service and use it to attract people in? Do I roll it into a parking cost? Do I put a quarter in a parking meter? I don't want to propose particular directions to go with those business models. You can see that there's lots and lots of options and models in the rest of the world. I will tell you that in some places in Scandinavia, not just Finland, They actually try very hard to make sure there's just basic outlets available where people park. And nobody cares when you park your electric vehicle in and start pulling energy out of it. And again, it's low cost per hour. So, nobody, I mean, you can't go in and pretend you're going to steal fast charging from a basic outlet. You can't steal multiple dollars worth of energy, even if you're parked for a few hours. And obviously, when you're parked a few hours, you're either at work or you're hopefully up in your bed, and you don't have to pay much attention to this. So yeah, I don't want to imply any limits. There are plenty of business models that can work here, and it may be that a lot of people decide, you know what, just take the covers off of the outlets, or make sure there are outlets in light poles, and put up a sign, EV charger.
Great, thank you. We had a comment that a lot of the street and parking lot lights have been converted to LED bulbs, and they would have the power available for level 2 chargers.
And the one small thing is that the folks who are putting together level 2 infrastructure are charging, maybe once the quantities come up, the economic pressure will go down. But I'm hearing people say, yeah, to install a level 2 charger, no matter what, you're looking at $1,500 a pop. Even if it's $500 or $600 a pop, you start to have to do some soul searching. Will we ever recover that cost in terms of energy? Whereas for a basic outlet, you can get the quantities way up, and it's harder to have the conversation about what's the price per each. Putting 100 outlets in a parking garage is not $600 a piece kind of a project. It's much more straightforward than that. So I go back to it and say, okay, how can I leverage and really get as much access as possible? And is it adequate? I absolutely. If people are coming into a small town and expecting to be there for a couple hours, level 2 charging is a big advantage. You don't get much out of the basic outlet, but for the residents and the people who work there, it's the other way around.
That's a good segue sort of into the next comment. Sounds like an EV owner. They said, I would not get my connector out of my trunk, plug into a 110 outlet at a restaurant for an hour, and then have to retrieve my connector when I leave for 5 miles worth of energy.
I agree with that 100%. You quickly figure out that when you're using the spare connector in the back of your car, if it takes you 2 or 3 minutes to make that connection, it's hard to convince yourself that that's worth it. I think the industry has gone the wrong direction. I wish that I could open the flap on my car and just reel out the cord and plug it in, instead of opening the trunk and grabbing that silly connector cord. But you're right, there will be plenty of situations in which the hour or two isn't very interesting, and it's the long term. So where the basic infrastructure really matters is at places where people live and places where people work. Places where they're parked for many hours at a time. And I think that's where we really want to see that work going. So, somebody asked about a 40-unit condominium. Obviously, one has to look at the maps and the parking arrangement. With basic infrastructure, you can talk about 40 charging points for a 40-unit condominium. When it's level 2 and those fancy items, and maybe you're talking about 3 or 4, now how are the residents going to cope with that and interact with that? It gets painful really quickly.
Thank you. We had a comment that it was in reference to your hourly pricing strategy for charging EVs. It says hour by hour pricing from ComEd. It's not real time, and you could end up paying more than you expect. So sort of a word of caution there, maybe with the hourly pricing.
And it depends, right? It depends on what rate people have negotiated and what rate is available. In many parts of the state, the utilities are permitted to do a next day hour by hour rate, but that's fixed the day ahead, so you know what it is. In other parts of the state, the utilities are permitted to do true real-time pricing. And yeah, absolutely, that's a little bit different. In either case, there's plenty of communication capability ultimately that's possible within the vehicle. And the driver can simply decide, if the price is this high, don't use this outlet, or whatever that might be, right? One of the things I would like to emphasize, because I see some comments on this, right? Lots of people are really trying to emphasize fast charging. And again, very important for distance travel, but also quite stressful for EV batteries. I don't want to walk through the math, but we've done some of this kind of work, and basically every time I try to charge an EV battery to say 80% in 20 minutes, I might be pulling as much as 1% off of its long-term life. And I want to do that trade-off deliberately, but I certainly don't want to do it routinely.
That's good to keep in mind. We had a comment that this person said they also see issues related to battery and warranties and charging, sort of like you've had bad gasoline, which impacted your engine. I hope EV manufacturers and deliverers of electricity will work it out so consumers aren't stuck in the middle. So some concerns over possibly voiding warranty batteries or having too much current. I'm not exactly sure what the comment was, but maybe you have some insight on that.
Sure, I can make a couple of comments on that. I mean, one of the wonderful things about using basic infrastructure, and that, by the way, would include maybe the 220 volt, 12 amp kinds of things, is it simply cannot push the batteries very hard. So the notion of a warranty issue or whatever in that situation is really not plausible. I mean, you just can't pull power fast enough to have impact on battery life from that kind of basic infrastructure. For fast charging, it's a little bit different story. And I think that we're going to see, I'm not worried, because I think we're going to see very significant certification requirements and so forth for fast charging, because the energy rates are high, the equipment is complicated. There will be specific industry and technical standards that will have to be met, like UL standards and other things. But for basic infrastructure, if you can get it, it's great. The other comment I'll make, though, one of the big problems right now with level 2 chargers that exist in some places, right, is the line cord comes with it. And that's great, it's convenient, sounds wonderful. And many of us have the experience that I go in the parking garage, I use one, oh, it's not working. I go to the next one, oh, somebody has vandalized or run over or otherwise damaged the cable. I go to the next one, oh, it's not working either. I go to the fourth one, oh, okay, finally I got one that's working. Much easier with basic infrastructure. It doesn't mean it's immune to damage or other things, but I think we all have the experience that it's more likely that just a basic outlet is going to be functional in a given situation, rather than one in which there's this cord hanging there and maybe sort of a target for potential damage. And that's an interesting long-term consideration.
Excellent.
By the way, let me hit another one that somebody said. The 120 volt outlets shown are 20 amp outlets, meaning that they could support 2400 watts. Yeah, the wiring can support that. The UL standard actually says you're not allowed to go above 80%. for anything that's connected more than 3 hours. And unfortunately, we'd like to be able to accommodate both 15 amp and 20 amp outlets, and that puts you at 12. Yeah, in my garage at home, I use 16 amps, but there are rules behind all these things.
Great point. We had a question that's sort of asked and answered. Is there any issue with charging your garage with circuit breaking? And somebody said properly wired, there is no circuit breaker issues with the level 1 or level 2 charger. I can also personally testify I've had level 2 charger at 30 amps in my garage for 4 years with no issues whatsoever. So I think level 1 and 2 charging is perfectly safe and capable within a home. Is that correct?
I think this is a key point, right? The basic outlets are straightforward, typically readily available, usually have an appropriate amount of protection. At worst, you have an electrician come in and add an extra circuit. The so-called level 2, the 240 volt 30 amp, is equivalent to mounting a dryer outlet in your garage. All of this, of course, is very straightforward and really doesn't push the typical needs or design requirements. One small issue, if I'm especially if I'm in a rural area out at the end of something, and suddenly all my neighbors have electric cars and everybody puts in a dryer outlet and they're all charging at 240 volts and 30 amps, I can begin to get into trouble overloading the local transformer and other things. If everybody's charging all at once, it adds up pretty quickly. For basic infrastructure, for 120 volt outlets, 120 volts, 12 or 16 amps, that's almost impossible. Having 10 neighbors all charging at once is not any different than everybody baking a cake in the oven at more or less the same time. And the system is a little bit more designed for that kind of thing. So I think it's interesting to see where that can grow.
Great. We had a question. When you talk about normal outlets, is this assuming 220 or 120 or either? Are both considered slower, cheaper, and less stressful on the battery?
The first part of that is I'm trying to suggest that when we have, say, a parking structure or an urban environment or anything else, there's no downside into putting in just really basic 120 volt outlets that people can get to readily. Very low cost. We all understand the safety, easy to put in. Hardware isn't a big issue. The demand push back into the grid is modest, pretty straightforward. In a residential environment, if you can do it, sure, have the electrician put in the 220 volt 20 amp outlet. It's a little bit easier, a little more convenient. Some people always call that level 2. That's kind of semantic. Sure, it's a little faster and a little more convenient, may or may not be necessary. So, I mean, I think it's more a question of scale. If I want 100 million outlets, I probably want to use 120 volts, and I can get that to everybody. I'm not sure I really need to go to 220.
Excellent. We have a poll question if folks wouldn't mind answering on the screen as we continue to ask some of the questions. We had a question. Do you have any vendor design recommendations for solar outlets? Many of our parking areas do not have access to any electric infrastructure.
Yeah, that's a nice question. There's a couple of ways to handle that. It's not difficult to get solar panels today with sort of built-in inverters. The power level is pretty low, and not clear that you can pull even 12 amps out of probably not a single panel, but a small group of panels. You would be able to do that basically when things are available. Many people are trying to do combined solar panel and battery and outlet kinds of things. certainly works very well, pretty convenient, a little bit more expensive. Batteries are not cheap, but an interesting way to do stuff sort of in an area where there's no access at all to electrical energy. But yes, we have seen, especially in California, there are some sort of solar only parking lot canopies that are used with very basic charging infrastructure. And it's kind of a, either you can get power out of the outlet or you can't. So at night it's not going to run, and during the middle of the day it's fine.
All right, we had a comment that parking lot lights are now currently, pun intended, draw less current with LED retrofits. Mounting a simple EVSE connection or reliable power outlet enabled by a central monitor management system. Think OCPP standards.
Yeah, I mean, I think there's a huge opportunity there, and it's not clear to me whether we really need to have central management for it. Hard to tell. I mean, you got to have some management to turn it on and off. Obviously, the lights themselves have some controls in them, but it's a question of the trade-off for the energy cost. Certainly on a campus like mine, where there's a fairly substantial annual fee for parking, I think our folks have been convinced that 17 cents worth of energy an hour is almost not worth billing relative to what people are already having to pay for parking. Obviously, we can imagine plenty of other scenarios where the parking is free and you need somebody to pay for that energy, and then you would do it a little bit differently. Yep.
We had another comment. I did 1 year with only one level 1, but BEV drivers quickly embrace level 2 chargers and stay away from the level 1 chargers.
In my experience, I mean, I know plenty of people who actually decided not to put in the level 2 at their homes and use the level 1. And after a couple months, they realized that, oh, this is just fine. Everything's working fine. Obviously, there are other folks who kind of get used to that little bit quicker, time frame. I mean, at my house, I always use my true 20 volt outlet. That's the only thing I have an adapter for. But we will see people's behavior adapt. I think the straightforward thing is, if I can go to work and find a basic outlet there, I'll use it. If I see the level 2 with the cord, I'll use that. Certainly if they're both free. If somebody's charging me 50 cents a kilowatt hour for the level 2 and 10 cents a kilowatt hour for the other one, I'm going to make that choice. So it doesn't take a lot of economic incentive to kind of put people in those directions.
We had a comment for people that keep their cars at least 10 years, sometimes longer. What about battery replacement in the car? I've heard that an EV battery is about 3/4 of the cost of the total car, I'm assuming, and can wear out after 60 to 70,000 miles or 8 years. With a gas car, that vehicle may be able to go 150,000 miles if taken care of, or last 15 years.
It's early days. Hybrid vehicles are seeing actually much longer battery life than that. The numbers being quoted there are actually typical warranty numbers that people are doing for electric vehicles. I certainly, it's a little bit anecdotal, but we have seen people who are getting 200,000 mile kinds of lifetime from their EV batteries. So actually, I think, well, let me put it this way: the field data are showing that batteries are lasting longer than many people had expected. So I think we can be very optimistic about that. I don't think EVs are going to see many cycles of electric vehicle replacement. But it is early days. There's not that many cars that have been out there for 10 and 20 years. Most of them are the Toyota hybrids. We do have some experience with them, but we need more experience with the lithium-ion batteries and the Teslas and others to really come up with anything very conclusive.
We had a question. Can you give a rough estimate of how much it costs to charge a plug-in hybrid electric vehicle overnight for its 20-mile range using a
Yeah.
typical hammering rate?
Sure. 20 miles, very roughly 250 watt hours per mile. So that's 5 kilowatt hours. And if one is getting billed, what was the number there? I think they said 20 cents a kilowatt hour, right? 20 cents a kilowatt hour, 5 kilowatts is, $1. Plug-in hybrid overnight at the retail rate is actually quite a bit less than that. I can tell you, maybe I'm a little embarrassed to tell you, I plug my plug-in hybrid car in almost every day, and frankly, I haven't really seen any impact on my electricity bill. It's less than $1 a day kind of thing. The heating in my home is costing a whole lot more than the car. Now I live in Champaign. That experience is not going to be typical, but it's so much cheaper than fuel. It is so much cheaper than fuel.
Dr. Crean, I don't know if you had a hard stop at 1 or if you'd like to just keep rolling.
I do have another meeting here coming up momentarily.
Okay.
I'm trying to look through here and see if there's other things that we need to hit. One of the questions was about the increase in supply demand. Once we have transitioned all transportation to electricity, that overall implies almost a doubling in electrical energy demand. So no question there'll be some grid growth. What I can tell you is that right now, most of the grid growth in this part of the country is actually in solar and wind. And indeed, the growth rates are sufficient to keep up with the projections right now of how quickly electric vehicles will begin to come into play. So it'll be interesting to see how that works out. But the trouble with solar and wind is they're variable. And it's hard to predict exactly what's going on with them. On the other hand, the good thing about electric vehicles is they're flexible. So if we can put these two against each other, it becomes very interesting.
Great. Dr. Crean, would it be okay if folks have a really pressing question to email that to you later, perhaps?
Absolutely. Absolutely.
Okay, great. So we will provide Dr. Crean's contact information with our follow-up materials that we send out. And sorry for, it's sort of a hot topic and very popular, so we couldn't get to all the questions, but we really appreciate everyone's attendance today. And if you do have a pressing question, perhaps you can just email Dr. Crean and he can try to answer that for you. Thank you so much for participating in today's webinar, and make sure you visit our site to register for future webinars, and that's go.illinois.edu/LGE, and you'll be able to find information about our upcoming webinar offerings. So once again, thank you so much.
And thanks to everyone. Thanks to the audience. Glad to see active participation. And I hope it gave you something to think about, maybe to think a little bit differently about what we can do with this.